One of the most common errors that are made in the calculator is when you square a negative number. So here we have negative 17, and we want to substitute it into x squared. So we put negative 17 squared into the calculator, and it tells us negative 289 for an answer. Is this right? Well, it's not right. The calculator is following its order of operations. So it's squaring the 17 to get 289, and then it puts the negative sign on it. The negative sign is actually the same thing as subtraction. So what you want to do is to make sure that you put the negative 17 completely in parentheses. Put parentheses around the whole number. This way you'll get positive 289, which is the correct answer. In fact, it doesn't hurt to put parentheses around negative numbers no matter where they are in the expression that you're evaluating. I'm sure you already know that when you do division on the Nspire, oftentimes you get a fraction for a result. And I also know that you're aware that if you press Control Enter, that will convert that into a decimal. Now you can press Control Enter during the calculation to get a decimal answer from the start, or after you get the fraction answer. But you can also go backward. You can start with a decimal number and get a fraction approximation. So what you're going to do is start with a fractional number and press Menu to 2. And that's going to give you the approximate to fraction function, and it will turn that decimal number into a fraction. When you're graphing, make sure that you understand that your graph window is going to be the only part of the graph you're able to see. For example, if I graph this quadratic, press Enter, where is the graph? Well, of course, I need to zoom out. Don't assume that you did something wrong or that the calculator's malfunctioning. Go ahead and zoom out until you can see the graph. Now, if you need to zoom in to do some more work with it up close, you can go ahead and do that. So first thing you should check if you don't see your graph is to zoom. I'm going to call these simple inequalities because these are the ones that have only y on one side, and so y greater than, y less than, and so on are going to be the types of inequalities we're talking about here. And the way you enter these in the calculator is just to erase the equal sign and replace it with whatever inequality sign is required for the problem. You'll get a little pop-up menu that's going to allow you to pick greater than, less than, greater than or equals, less than or equals, or go back to equals. When you enter the function in, it's going to shade those regions where the x and the y value make the expression true. For example, if I graph this quadratic, erase the equal sign and it brings up the little pop-up menu. Now I want y is greater than, so I'm going to pick 4 off the menu. That changes to y greater than, and I'll type in the rest of the expression. When I hit enter, I get a shaded area, and for example, this point where the arrow is pointing to, 4, 5, makes this expression true, as would any other point in the blue area. If you take 4 from the point, the x value, and put it into the equation, and then you put 5 for the y value, you'll end up with 5 is greater than 3, which of course is true. If I were to take a value outside of the blue area, for example 0, 0, and put that into the equation, I would get 0 is greater than 19, which of course is not true. So the blue area, every x, y coordinate in there is the x and y value that makes the expression true. Now we'll switch to what I call the complex equations and inequalities. So this is where you have an expression on both sides, not just y is greater than or less than. So for example, you might have x squared plus 3 equals x plus 4, or you might have an inequality log x is less than 5 minus x. What you're going to do is make two graphs for each of these equations. So for x squared plus 3 equals x plus 4, you're going to make two graphs. X squared plus 3 will be one of them. That's the blue parabola. X plus 4, the red line, is the other graph. You're going to look for the intersections. Menu, 6, 4. And that's going to mark those 2 points. Of course, you'll have to do that twice, but the two intersections here are going to be minus 0.618 and 1.62. If you look at the graph, you'll see that those are the x values of the intersections of the two graphs. Now things are a little bit different when we go to inequalities. Instead of individual points like we had with the equality, with the equation, we're going to have actually a span of numbers or a range of numbers that are going to make that expression true. So one way to think about this is to look at the different colors of the graphs. We have log x on the left in blue, and we have 5 minus x on the right in red. And if we simply recast this problem as where is blue less than or equal to red, we can see that it's certainly true in this range. It's not true to the right of there where we have blue greater than red. But the question is, what happens to the left of the y-axis? And this is a little bit tricky because if you notice, the log graph, the blue graph, runs out at x equals 0. We do not have a value for the log function at x equals 0, nor do we have any values for x less than 0. So for all of this range, these numbers are not in blue's domain, and it doesn't make sense to talk about red being greater than blue because blue does not exist there. And so the solution for this is going to be only those values from 0 up to and including 4.36. One of the most common types of questions that you might see is where they'll give you a function, an actual algebraic function, and present you with 4 graphs and ask you which of those graphs is the inverse of that function. So what you want to do is to graph the function first that they give to you. So let's just suppose it's x squared plus 2x plus 2. If you want, you can graph the reflecting line. This is totally optional, but it does help you kind of visualize things. It's pretty quick and easy to do. Just enter x for the graph. And now what you want to do is to enter some text. You're going to go to menu 1, 7. This is going to allow you to enter a text box on the screen. Now, you must type x equals f1 parentheses y. If your function, your parabola in this case, or whatever it is you're graphing, happens to be f2 or f5 or f anything else, you have to have the same thing in the x equals. So in other words, if my parabola was f5 of x, I would have to put x equals f5 of y. Once you have that, press enter to lock the text in place, and then escape to get out of the text editing mode. The next thing you'll do after that is grab the text and just drag it down to the x-axis. When you do that, the graph of the inverse will appear. Lines sometimes have to be entered in standard form. What is standard form? That's where you have the x and the y on the left and a number on the right. Here's an example, 4x minus 6y equals 12. So why would we mess up a perfectly good mx plus b with this mess? Well, if you remember from working with systems of linear equations, what you're going to see is usually x and y on the left side and a number on the right. So what we need to do is go to menu 3, 2, 1, 3. Okay, that's a lot of typing there, but we're going to change the entry edit method to an equation, pick a line, and finally pick the standard form, option 3. Now when you're done, after you've put your line in, you need to go back and press menu 3-1 to eliminate the standard form template editing mode that you're in. What you're going to see here when you go into the mode is this little template down at the bottom. You're going to enter the coefficients for x and y and the number c on the right. So for our example, we're going to put in 4x and negative 6 in front of y. The negative 6 is to make that into a subtraction. You notice that the plus sign is part of the template and can't be changed. So in order to subtract, we actually have to add a negative. When I press enter, it gives me a line. Linear regression is when the calculator is going to find the equation of a trend line for a scatterplot. So you want to start off with a list and spreadsheet page. This is going to be option 4 from the main menu. This is like the table that you're going to enter. First thing you want to do is make sure that you put x and y into the column headings at the top of the table as you see on the screen here. After that, go down to row 1, put in your xy pair, go to row 2, put in the next xy pair, and so on for as much data as you have. Once you have the data entered, press menu 3-9. This gets you to the quick graph. When you do that, what happens is the screen gets split. You have the table on the left and you have your graph on the right. Now, if you look at the graph on the right, as I have it on the screen here, I have the graph all set up nice and neat. That's not going to be the case when you first do this. you're going to have to click down at the bottom and change the label on the horizontal axis to X, and you're actually going to have to add the label on the vertical axis and call it Y. Once you do that, all the points will move into position. Now that you've got the graph set up, you're going to press menu 4 for analyze, 6 for regression, and 1 for linear regression. This is a line. We want mx plus b. Click that, and the calculator will draw the line and give you the equation. Now this equation, if you're on a split screen, is probably going to run off the side of the screen. You want to be sure to grab that and pull it to the left so that you can see the whole thing, to be sure that you've got all the numbers. Another option is to press Control 6. That's going to separate the graph and the table into two separate tabs. You'll have a lot more room to work with, and you should be able to see the equation more clearly. By the way, you can fit other functions like quadratics, exponentials, or anything else by just selecting a different regression model when you get to the menu 4-6 selection. If your data is not looking like it's following a straight line, if it looks like some kind of a curve, you might pick a quadratic, you might pick a exponential or a log, something that might fit into that data. We know we can solve systems of linear equations by graphing because systems of linear equations are just lines. And where those lines cross are the solutions for the system of equations. You have to keep in mind that, of course, you have to graph each equation one at a time, and the equations could be in standard form, or it might be in some other form where you have to solve for y before putting it into the calculator. The calculator will only accept something that looks like y equals or f of x equals, or you can convert to standard form using the information that I gave you earlier in this presentation. Main thing to remember is that the intersections between the lines, or between whatever graphs you're putting in there, the intersections are the solutions. So for example, if we have this system of linear equations that you see in the lower left, the solution is 1.17 for x and y is negative 1.83. I'll graph one line. This happens to be in standard form. I stay in standard form mode to put my second line in, x minus y equals 3. And then I find the intersection, and that's where I get the value of x and the value of y. Those are the values that make that true. A much quicker and easier way to do this is by using a function called linsolve. Now this is not something you type in. What you do is go to menu 3 and 2. A box is going to come up asking you how many equations you have and what your variable names are. It defaults to 2 equations and the variable names x and y. And if that's what you have in your problem, then you just go ahead and keep that, press OK. Otherwise, you can change it as needed. You're going to put the equations into the boxes that come up exactly as they were written. So you're going to get a screen that's going to have a couple of boxes. You put in your equations. If you look down below, you'll see that those equations happen to be in standard form, but they could be in y equals mx plus b form or any other combination. Now, if your solution is a number, as you see next to the blue arrow, if it's a pair of numbers like that, that means that x equals negative 2, y equals 3. That means you have a unique solution. You have 2 lines that are crossing. Another possibility is that you end up with this answer that has this C1 or C2 or C5 or whatever in it. And what this means, without going into the explanation about it, is that you have an infinite number of solutions. The 2 lines are actually the same line, even if they look different. And then finally, it's possible that you have parallel lines, in which case you'll get no solution, and linsolve is pretty explicit about that, no solution found. Analyzing quadratics graphically is pretty easy. You want to go to your menu 6 function, and then you're going to have the option to find the vertex by looking for the minimum, which is number 2, or maximum, which is the number 3 option. You can also find the x-intercepts, which are x1 and x2, by selecting option 1, which is for zeros. The factors of the quadratic are going to be x minus x1 times x minus x2. So using the calculator to find those x-intercepts will actually help you to factor the quadratic. Let's factor this quadratic, minus 2x squared plus 2x plus 4. Here's the graph. We went ahead and found the vertex just for fun. That's going to be a maximum in this case because it's the highest point on the curve. Its coordinate is 0.5 and 4.5. Now the zeros, or the x-intercepts, are at x equals -1 and x equals 2. So if I have x equals -1 as a 0, one of my factors is x minus -1 or x plus 1. The other factor will be x minus 2. So on the left here you see the zeros and the factors. The factors are kind of opposite from the zeros because we want the factor to be 0 when x is the value where it crosses. The factored form is all the way at the bottom. If you have an a value or a sign in front of x squared, we have a -2 here, that has to go in front of the factors. Perhaps an easier way to analyze quadratics for factoring is with the function called cpolyroots. Cpolyroots will give you the real or the imaginary roots for any quadratic. Basically replaces the quadratic formula. The only restriction is that you have to have the quadratic set equal to 0. And in any case, you're going to have to do that even if you use the quadratic formula. So for example, if you have x squared plus x equals -1, you're going to have to move that -1 over to the other side to make the right side 0. X squared plus x plus 1 equals 0. Once you have that quadratic in that form, you put into the calculator cpolyroots, the quadratic, and don't forget the comma x. You have to tell the calculator that x is the variable. When you do that, you get one of these kinds of cases. The very first one is a result that has two real roots. You can tell that because you have -1 and 2. They're different numbers. They're both real numbers. The second example there is when you have one real double root. This is where the parabola touches the x-axis only in one point. And that point in this case is x equals -1. The last case is if the parabola does not touch the x-axis at all, you have what we call imaginary roots. You can tell that that's the case because of the letter I that's in bold in the answer. And finally, if you need to graph asymptotes or vertical line, here's how you do that. You do have to do this manually. The calculator does not have a function for finding asymptotes. So you have to calculate whether that's going to be a horizontal asymptote, y equals some number, a vertical asymptote, x equals some number, or just a vertical line, x equals some number that you want to plot. Remember, horizontal lines are going to be y equals a number, and because it's y equals, you can just put that into the calculator as if it was any other function, and it will give you the horizontal line. Vertical lines and vertical asymptotes are a little bit different because their equation is x equals a number, and you can't put that in directly. You have to go back to that menu where the lines were, where we did standard form, menu 3, 2, 1, 2, and select the x equals c option. That's going to allow you to enter a vertical line. So here it is down at the bottom. 3 gets you to the graph entry edit. You're going to go to equation mode, which is 2. That'll bring you to the menu on the left there with all of the shapes. You're going to select 1 for line, and then option 2 finally for x equals c. Down at the bottom then, you're going to end up with x equals, a little template. You're going to fill in, let's say, 4 if you want a vertical line at x equals 4. Press enter. There's your vertical line. The only other thing you have to remember to do is to reset the mode to function mode. In other words, if right now you went back and wanted to put in f of x equals x squared, you couldn't do it because it's still in the mode for x equals for vertical lines. So to reset that, you go to menu 3 and then just press 1 for function, and that gets you back to normal. And then finally, you can put in the horizontal line, as I said, by just setting whatever function it's ready to graph equal to whatever number you want the horizontal line to be at. So horizontal line at y equals 2, I'm just going to go ahead and press tab in the function mode and just enter 2 and get the horizontal line.